we have a product called Hyperion. So what makes Hyperion different from other energy intelligence products? Well, Hyperion is based on commercial satellite data to track frac crews. We are the only company in the world that truly tracks frac crews. There are a lot of other frac crew based products out there, but what they are doing is they're actually taking a sample of data from either fracfocus.org or the public low resolution, low frequency available satellites, and then they're trying to gross that sample up to the total number of frac crews. And that's not what we do here. Our value add for energy intelligence is we take medium resolution commercial satellite images, thousands of them every day, to monitor all of the well pads in all the major plays of the lower 48 with potential to frac or drill. And we monitor these crews in near real time and make that data available to our customers. So in the webinar today, I'm going to be introducing 4 new products that we are going to be making available to our customers. These products are ready and they're going to go online for existing Hyperion subscribers on Monday. So if you are currently subscribed to Hyperion, you're going to be getting an email this weekend with instructions summarizing the main points of this webinar, which is also going to be recorded for your benefit, and explaining to you how you can access and make use of these new data sets, which we've been working on that are going live shortly. So we take thousands of satellite pictures like the one you're seeing here of frac jobs all around the US, and we aggregate that data together. So we make it available at the well level, but we also add it all together to give a clearer picture of what oil and gas completion data or oil and gas completion activity is like around the US. So how do we compare to other data sources? Well, I think the next best way to really assess fracking data around the US is probably with fracfocus.org. If you're not familiar with that, it is a voluntarily reported website of frac jobs where E&P companies on a complete volunteer basis can post their frac jobs on there, and they capture about 70% of the total frac jobs. You can see we capture 30% more than FracFocus does. But what's more interesting than that is we also can compare the frac jobs that we're seeing from our high frequency satellite images to fracfocus.org, and we have found that 10%, around 10%, a little bit less than all of the frac jobs reported to fracfocus.org are actually not legitimate. We have photos of the well pads that are allegedly being completed. There is no frac crew there. And what's more important, you see how fracfocus.org data is dropping off here. It, of course, is reported on a lag, generally a 4-month lag, whereas our data is not. We release a new data set of 3 days of daily data every 3 days to our customers. But we're monitoring the entire well pad life cycle. So if you look at how our data compares to the next best data source in the industry, Baker Hughes, which is a rig count that's been around for a long time, let's not forget about the rigs. We're capturing on average 15% more rigs than Baker Hughes does. And that's because Baker Hughes uses a survey-based method to assess what rigs are drilling. Well, with satellite photos, we can capture the rigs that don't want to participate in the survey. That number ends up being about 15%. All right, so like I mentioned earlier, we've got 4 updates for all Hyperion subscribers, 4 new data sets that we're real excited to release to you, and I'm going to talk about the significance of each one at a time here. But to give you a high level summary of what we've got, the first one is the next regional release of the short-term forecast. If you joined us in our previous webinar, we talked about the short-term forecast. It's a bottom-up, well-level satellite completion derived forecast of production. We released it initially for Haynesville, Texas, and we have now completed it for Haynesville, Louisiana. So at every update, every release of new Hyperion information, you're now going to be receiving Haynesville, Louisiana as well. Where we stand on the development of that, because the goal, of course, is to expand that short-term forecast to the entire lower 48 for oil and gas. We are hoping that by the end of Q1 in this coming year, we're going to have this done for all of the regions in the Gulf Coast. We're prioritizing the Gulf Coast because, as we'll get into in a minute, this data is particularly meaningful for areas where pipeline scrape models tend to be less accurate, and that would be the Gulf Coast right now. We're also today releasing the long-term forecast. So the short-term forecast, it only looks out about 2 months into the future. That's the immediate predictability from looking at well-level completions. The long-term forecast, it goes a bit longer. It goes 12 months, and we're releasing that for every single region. So you can aggregate that all together into a total lower 48 forecast, and we'll talk about what makes that forecast unique in a moment. Today, we're also releasing our daily production model. I'm sure many of you are familiar with pipe scrape models. This is related to, but not the same as a pipe scrape model. I'll explain what the differences are for that, but that time series, which will be updated daily, is going to be going out to all customers. And then finally, we are releasing a much needed facelift to our front end portal. We've gotten a lot of fantastic feedback from our customers about what they like and what they wish they had feature-wise on our front end portal. So I think everybody's going to be a lot happier with this new version, and we'll be giving access out to that soon. All right, so let's talk about the short-term forecast. What makes the short-term forecast different from, I think, its closest competitor, which would be a daily pipe scrape model? Well, it is highly accurate. For the two regions that we've done so far, like I mentioned before, we already released it for Haynesville, Texas. When we backcasted it with a holdout data set, the mean absolute error came in at 0.1 BCF a day, which means it has an accuracy level of 98%. Haynesville, Louisiana, obviously a lot more production on the Louisiana side than the Texas side for Haynesville. It had a mean absolute error of 0.2 BCF a day, which is the same 98% accuracy. Also, I think it's important to remember it is a completely independent look at near-term production, which I don't feel like there are a lot of options for that. Outside of a daily pipe scrape model, there really isn't any good source of production information, right? Obviously, we get the the weekly EIA storage numbers, but that doesn't tell us production. That just tells us the balance, right? What's going into or coming out of the ground. So this is a much needed second look at production in near real time that previously has not been available. And then finally, it's proprietary, right? This is exclusive to SynMax. We're the only company tracking frac crews, and only if you track the frac crews, if you bring that down to a well level granularity, can you create a forecast like this? You can't create it out of a regional estimation of frac activity. You have to have that well level information in order to get meaningful accuracy levels to where you can use it. So, SynMax, we're a new technology startup, which means that this information is providing alpha right now to traders, right? Someday, in the hopefully not too distant future, when we are a more widely adopted technology for trading, I imagine it's going to be more of a beta, but right now I feel like our customers are getting real alpha out of this. All right, so first off, let's talk about the short-term forecast in the new region that we're releasing. Some of this is going to be a review from the previous webcast, but I feel like it's good to kind of contextualize the conversation and maybe refresh it a little bit. Basically, the primary problem we're trying to solve is the problems of the pipe scrape model. A little bit review, everybody already knows this, but you can see the flows, both receipt and delivery, off of interstate pipelines, but you can't see them off of intrastate pipelines, right? So the distinction is pipelines that cross state lines are regulated by the FERC, and we can harvest that information and use it for analysis. Pipelines that do not cross state lines are regulated locally, and they are not under the same obligation to post that information. So while there are regions that have very good samples, and we can establish very tight relationships between certain receipt and delivery points and things like production, the sample is always changing. If you look at a pipeline map of the US, it looks a little bit like a bowl of spaghetti, and gas is constantly moving from intra and interstate pipelines. And as those samples change, as intrastate pipelines get expanded, like happened here on this graph in Haynesville, Texas with the CJ Express expansion, the sample changes. The problem with that is that we can only be reactive to it with today's technology, right? You can only wait until the 4-month lag state data comes in and tells you that your pipe model is missing because the sample has changed in order for you to make a change and then correctly recalibrate that model. So what ends up happening are instances like this, where in Haynesville, Texas, at the big black line here, we had a expansion of an intra-state pipeline. More gas started flowing where we couldn't see it, and so the daily pipe models, many of the daily pipe models that were published by our competitors, were underrepresenting production in Haynesville, Texas, right? Whereas the actual production profile was following this orange line up here. We know now, because we have the benefit of the state data in hindsight, many people following the production on the pipe scrape model were completely missing it and scratching their heads when the EIA numbers were coming in wrong, right? So the benefit of the short-term production model is that it fills this gap, right? If this is the last good data point right here, then this gray line fills in for the state data. And since it has proven to be highly accurate within 0.1 BCF a day mean absolute error, right? then we can reliably know when these associations are changing. So we can react to them, we can recalibrate our models faster, and we can also get a good second independent look at what production is doing on every region where we're making this available. And the way that we're able to do this is because we're monitoring the entire well life cycle, right? So our satellites are watching the well before the rigs show up. We see the rig arrive, we see the rig leave, we see the frac crew arrive, we see the frac crew leave, and we continue monitoring it until the turned in line event occurs, until we see production showing up from the state data. We continue to monitor it. So the real point of predictability, which is where our forecast gets its legs, is when the frac crew shows up. Because once the frac crew shows up, we can reliably predict how long the frac crew is going to be there. Because it is very simply a function of the number of wells and the lengths of the laterals of those wells on the well pad that can reliably tell us how long the frac crew is going to be present. And then after the frac crew leaves, we can also model what we call the TIL lag, the turned in line lag, the period of time after the frac crew has left, but before hydrocarbons are flowing onto the pipe. That tends to be a function of who the operators are and what regions the well is in. And with that, if you add these two distances together, you get about 60 days, which means our short-term forecast, it not only takes the 4-month lagging state data and trues it up to the present, we get a short-term forecast of about 60 days. And the way we do that is we use, very well studied, very well proven IP rate models and decline models. And we create these profiles for the individual wells that we're seeing with satellite images getting completed, and we stack them together into a total production profile. All right, so that's the short-term forecast, probably a review for a lot of people. Now let's move on to the long-term forecast, which, like I said before, is 12 months. So the long-term forecast is based on a slightly different method. It's a different model, but you still may be familiar with it. It's called the producer survey model. And it is, in my opinion, the most accurate way to model natural gas production into the future, looking outside of the range of the short-term forecast. So the producer survey model is very simple to understand. You just listen to all the earnings calls of the public companies. You write down what their expectations are for their quarterly and yearly production increases or declines, right? You group all of that together, and then you assume, this is the big assumption that comes and the weakness from the traditional producer survey model, that is going to be representative of all production in the US, right? So I pointed out the problem with this. The problem is that 49% of natural gas production is actually coming from public producers where you can listen to the earnings calls, right? The other 51% is coming from private producers where they don't make those disclosures. So in the past, if we look at the chart on the right here, which is a chart of fracking activity by public and private producers, in the past, this hasn't been an issue, and this model has been very accurate because that assumption of public and private activity is going to behave similarly has been correct. However, recently we're seeing huge divergences. If you've read our previous research reports, you know a little bit more detail about that in the behavior of public and private producers. They seem to be operating with very different mindsets and strategies, and that creates a big weakness for this. But it also creates an opportunity when you have SynMax data, right? So our data gives us insight into the differences of behavior that are currently happening and what we should expect for the future of public and private companies. So we can start with the same well-proven producer survey model for public companies, and then we can use SynMax data, right? We can look at DUC activity, fracking activity, drill activity for these private producers and come up with a reasonable, educated estimate of what the public producers are going to do versus the guidance, and group that up to a total lower 48 picture. And that's what we've done with our long-term forecast. So the long-term forecast, unlike the short-term forecast, which can be taken all the way down to the well level, it is grouped up to the sub-regional level, but that makes it very easy to compare to the daily production model, which is the next update I want to talk about. So daily production model, like I alluded to earlier, very similar to a pipe scrape model. In fact, that's one of the big data sources that go into it. But it's more of a composite model. It's more of a model that uses all the sources of information, 3 primary sources of information, to try and help get the best possible view of daily production that can be constructed. It starts by reconciling state production data against EIA, right, to make sure that the state production data can be reliably used to get a close view of what the EIA is thinking production is. And usually that is a nothing exercise. The EIA uses state production data when they're grouping together what they think production is. And then we use the EIA data as well as state production data, oil and gas ratios to construct dry gas factors. That's an important step because state production data is what we call wet gas. It's gas coming straight out of the wellhead that contains propane, butane, and ethane in it, has not yet been processed and had those petrochemicals stripped out of it. But the gas we care about, the gas that goes into storage and that gets consumed and traded on the market, is dry gas. And so the EIA and the state production data give us these dry gas factors that we can then use to reliably use the state production data as a part of our daily production model. So the more historic portion of the daily production model is state production data with pipeline data, basic shapes adjusted to it so you can get a daily profile. So you can study things like freeze-offs and pipeline outages accurately while still reconciling up to the state totals. And then the more latter part of the daily production model is pipe scrapes. But this is where we differentiate. The pipe scrapes are informed by the short-term forecast, right? And the short-term forecast is informed by satellite observations. So earlier, I was giving you the example of Haynesville, Texas. Let's go back to that, right? The CGI Express expansion was an instance where we had a change in sample in Haynesville. And by the way, we're probably going to have another change in sample to Haynesville coming here shortly, as the Gulf Run pipeline is going to start flowing gas soon. So the Gulf Run pipeline, thankfully, is an interstate pipeline. So it is going to post its flows, but it is also going to change the sample. And that regression, knowing what the relationship now to this new pipeline data to actual production, is going to be difficult to find until the state posts the data 4 months from now. Well, thankfully, SynMax has the short-term forecast model, so we can take an early look at what that state data is likely to look like and adjust our pipe regressions before anybody else can to give you the best possible picture of production. So that's something we're watching very closely. We're looking at the Gulf Run pipeline, watching for its flows to come on, and we will very soon be carefully adjusting our pipeline regressions accordingly to make sure that our customers are getting the best possible data. And by the way, this doesn't always go in this direction. We don't always get more pipeline scrapes. It's actually pretty rare. Most of the time we get less pipeline scrapes. What we're seeing in Texas right now is we're seeing more gas is going on the intrastate pipelines, right? The Haynesville is lucky in that we're getting this interstate pipeline coming on. In West Texas, for example, the Texas side of the Permian, we have a sample that is just falling and falling and falling as we have additional intrastate pipelines taking gas away. And Q1 cannot come soon enough, right, for the short-term forecast to start giving us an independent look at what's happening to production out there. All right, so to review very quickly, and then I'll jump into just a quick demo of our new front end, and we'll answer what questions we have time to answer. We are releasing the daily production model, which I just talked about. We are releasing the long-term forecast, right? We're releasing the short-term forecast. And by the way, the short-term forecast and the long-term forecast are tied out to each other. You're not going to get two different forecasts. The long-term forecast will equal the short-term forecast in the short run. We're also releasing short-term forecast for Haynesville, Louisiana, an expansion from what's existing right now, Haynesville, Texas. And then we're also releasing this new front-end portal, which is something I'm very excited to show you. So let me stop the PowerPoint presentation, and I will go to HyperionBeta.com. Which all of you who are Hyperion subscribers are going to get instructions to this. This is a temporary beta holding website for you to use, right? We're still going to keep Hyperion.synmax.com up and running, so you're still going to be able to use everything on there. We will gradually transition it over once Hyperion Beta, the new version of the front end, goes out of its beta phase, and we have all the features built into it that we want. So we'll keep that up for a long time to come, and depending on customer feedback, may keep it up indefinitely. But right now, you can access it at HyperionBeta.com. And what we've done is we've tried to alleviate the need for the traders and analysts that we support to have to rely on third-party tools to analyze our data. A real popular one is Excel or Tableau. We want to make it possible that you can do all of your analysis, not just ad hoc analysis, on our website. And the way we're doing this is we're creating these custom tabs, right? So you can see I've got a bunch of different tabs here, right, with different data sets that I've added in, and every one of these tabs is completely customizable. I can add in whatever type of time series I want. So every data set that SynMax provides is available. Everything from the completions and the ducts, the forecast production rigs, to be added in a customized time series on a customized tab. And then of course, when you leave, this is going to be saved. Down the road, we're also going to make it possible for you to be able to share these, right? You can send these tabs to other people in your firm, or even outside of your firm, other Hyperion customers if you're interested in that. But what I've done here for just a quick demo is I've created a new time series and I've added in Permian production, right? So one of the deficiencies I heard from way too many people was like, why is the Permian cut in half? Well, that's a long answer, right? Half the Permian's in New Mexico, half the Permian's is in Texas. And when I do my tie-outs, I do them to the EIA, and the EIA reports data at the state level. So I always had state lines as a divider in my subregions. And with this new interface, you can join those two together very easily. Whereas in the old interface, you had to make like 5 or 6 clicks in order to join them together. So I've done that here, and I've got the entire Permian, the New Mexico and Texas side, the daily production profile up here, and then I've got the green long-term forecast. And so it's very easy for somebody to come in here and see how is daily pipe production in the Permian coming in compared to our long-term forecast, and what are our expectations for it going into the future. All right, so that does it for the presentation. I guess now we're going to go into a little bit of Q&A. Let me stop sharing my screen, and I'll just read off the questions that we have time for. All right, first question. How do you guys account for an accurate timeline between frac end and TIL? My experience, it is challenging to get TIL data in real time. Yes, you are absolutely right. That does take more work than I think people would realize to get TIL, right? Because the issue is that we're talking about state reported data, which is always done at a monthly level. Yet in order for us to get an accurate determination of TIL lag, we need to report it in days, right? So the problem is that if you look at the state reported monthly production for oil and gas, the first month is almost always extremely low. And that's not to do with anything the geophysics of the well, that's just that you don't know which day it started on, but it probably wasn't the first day of the month, right? So a lot of people, to get around this, what they'll do is they will instead just use the second month, and they'll say that's my initial production rate. But really, you're underselling your initial production rate, right? So what you should do is you should use the clues of the decline profile from the second month on to back into what the initial production rate was. And then once you know the initial production rate, you can solve to see what day of the month the production likely came on. And that's the method we're using here, right? So we can back solve into what the IP rate is and use that to see what the first, or what day of the month production came on, right? That's how we get the production. And then the other piece we already have in daily, right? Since we're the only company that's taking daily pictures of these well pads, we know the day the frac crew left, right? We don't know the week the frac crew left. We don't know the month the frac crew left. We know the day the frac crew left. So we've got daily data to daily data, so we can model TIL lag. All right, next question. Will you have any other products besides Hyperion? Oh, I love this. Thanks for teeing me up on an easy one. Yeah. Okay, so for energy trading, yes, we've got a couple of cool things in the works. I don't know if you know this, but SynMax is actually working on a really cool project with maritime intelligence, tracking dark ships for potentially for governments around the world. Because we have a lot of proficiencies when it comes to the interpretation of mass Earth observation data from satellites, right? And there's a huge demand for this. So how does that fit into energy? Well, LNG and oil, right, all move on the ocean. There's some products out there right now. Kepler, right, is a really good one, but it all relies on AIS data. And for LNG, that doesn't really matter. Most LNG, like 99% of LNG is light. You don't need satellite pictures to know where a ship is. They're transmitting on the AIS network. But for oil, that is absolutely not true. There's a significant amount of oil that moves dark on the ocean. The vessels never turn on their transponders. They don't want anybody to see them. And the reason is because of sanctions. They're moving Iranian crude from Iran into India and China. And we have technology that can track them. We know right now ships that are breaking sanctions and moving crude. So one of our future projects is going to be a dark oil product. It's going to be a competitor to Kepler that is going to be tracking both oil and gas, right, in the same kind of way that Kepler does, but it's going to have something that Kepler can't do, and that is it's going to tell you the dark vessel movement, the dark energy movement around the globe, which I think is super cool. And then we're also in the, pretty far along in the development of a product called Vulcan, which is using a technique called photogrammetry. Basically, we can take satellite images of the same object from multiple angles, and then from that we can create a 3D model of the object. And so we are modeling all of the coal piles at all of the power plants of the US on a weekly basis, or that's what we're developing, right? That's what we're intending to do. I think we're up to 10 or 12 coal pile plants right now. And we intend to create a product called Vulcan that is going to tell you the weekly inventory numbers of all these coal plants. Okay, what's the next question? Oh, and then also I should mention, yeah, we are going to turn Hyperion into a full S&D product, right? So right now we are focusing on the production side because we think there's a lot of value to be had there, and it is 50% of the S&D. But we do want to get into the demand side, right? We've got all the pipe scrape data. We've got some proprietary industrial insights we can get from satellites about how industrials are running. So we do want to make a full S&D for the traders that subscribe. All right, last question. Besides the front end, how can I ingest your data? Another good question. Thanks for teeing me up for that one. I should have probably mentioned that in the presentation. But we have what I believe is the world's best Python library, right? At my previous job at Skylar Capital, I was responsible for ingesting a lot of these data sets, and they all came through APIs, which are HTTP request-based systems that would send you, a JSON of 500 rows of data at a time, right? So I tried to solve this problem when I built the Hyperion Python package, which is the best way to ingest data, by the way. Basically, one line of code, you can set your filters, you can tell it what data set you want. And we have data sets that are 300 million rows. Okay, our well production data set, 300 million rows. And our Python API library will push out asynchronous requests to our server. So like 16 simultaneous connections to our server. And it will take care of pagination, and it will compile all of that data back into a nice, clean pandas data frame. It is extremely performant. So the Python library, highly recommend you check it out. You can go to apidocs.synmax.com. We even have a video up there that shows you how to install it and get started downloading data on it. And then the last one is Snowflake. Snowflake is a super cool cloud-based relational database system that we have published our data to. So if you have a Snowflake account, all you have to do is send me the identifying information. If you're a Hyperion customer, I can link you up to it. You can get all of our data on Snowflake. Okay, apparently that wasn't the last question. We have another one. How do you handle false positives, frac crews or rigs staging in the field? Okay, this is a great question. Our ground truth data set is production. So when we're tuning our models and we're trying to determine what is an active frac crew, what is an active rig, what are we looking at as our ground truth set? We're not looking at the spud dates from the state. We've seen too many instances where those are wrong. We're not looking at frac focus. Like I mentioned earlier, 10% of those are wrong. Production is the winner, right? So when we see production being reported to the state, we call that a truth event. And we take all of our satellite images and our models and we tie it back to that. So that is how we are identifying a false positive. All right, it looks like those are all the questions that have been submitted to me. Like I said before, if you're a Hyperion subscriber, stay tuned. You're going to get an email with more instructions about how to access all of these new data sets, which are going live on Monday. Thanks everybody for your time. Hope you have a great holiday season.